All right, grade sevens, welcome to your next set of your next set experiment. This one's going to focus on the rate of dissolving. So how things. Oh, there's Gary Gold. Hey, Gary. He's looking to be fed. So, yes. Okay, Gary. Uh, the next experiment is the rate of dissolving. So last we spoke, we looked at different solvents and filtering, and we talked about why things dissolve and why things don't dissolve. And so just a quick recap. We said that in a liquid, we know that the particles have a somewhat weak attraction between them. So when we enter or put a solute into the solvent, for something to dissolve, the solute basically has to break the bonds of the attraction between the certain water particles. So the attractive forces of that particular solvent aren't strong enough to keep the solute from going in between and dissolving, and that's technically why things dissolve or almost disappear. In ethyl alcohol, things didn't dissolve because the molecules, or the bonds between the molecules of the ethyl alcohol, are stronger than water, and therefore the solute cannot force itself between those particular bonds, and things do not dissolve. So when you're looking at creating different elements or the sciences and how we combine things, it's very important to understand how to manipulate things and which solvents we can dissolve things in and which solvents we can't. So sometimes we may want things to dissolve, and sometimes we may want things not to dissolve. So we're going to look at another way we mix elements together. Okay, and you're going to look at 4 different ways we can dissolve something. Okay, and you'll be doing 4 experiments. It's going to involve sugar cubes. Okay, so there's your sugar cubes. Misha, don't eat anything. All right, these are very old. Don't eat them. Again, let me say this again. Don't eat them. So you'll be doing 4 different types of experiments. It's going to involve beakers of water, and you're going to need a stopwatch for this one. So you can use your iPhone, the clock at the back, or a stopwatch. So make sure you have a timing mechanism. So the first experiment we're going to do is you're going to take the water. Again, there'll be a bucket at the back for clean water and a bucket for dirty water. You're going to take a whole sugar cube, the first experiment, and again, you're going to have a chart. This time I'm going to provide the chart for you, and you can just kind of fill in the times, and it'll lay it out for you. So you're just going to get regular cold water. You're going to take a sugar cube, drop the sugar cube in, and time it, and see how long it takes to dissolve. So that'll be the first one. Then you're going to dump the water out, get a new beaker of water, again about 150 milliliters. Take a new sugar cube, drop the sugar cube in. Excuse me. This time you can use a spoon and give it a quick stir. Again, timing to see how long it takes to dissolve. The third experiment, again, take your water, dump it, new fresh water. You're going to take a sugar cube and you're going to crush it up into little bits, okay, like I have here. So you're going to take it, crush it up into nice fine bits, drop it in, leave it, and again, see how long it takes to dissolve. Then the last thing you're going to do, and this one you're going to need my help. So when you get to this one, what you're going to do is say, sir, I'd like to do the 4th attempt to dissolve something. And what you're going to do is you're going to get hot water. There's my lovely little sign. These are steam signs, so you're going to get hot water. So you have to give me a little bit of a head's notice. And what I'll do is I'll start the kettle at the back, and then when you're ready, you'll bring an empty beaker and a sugar cube. I'll we'll put it down on the table, pour the hot water, you drop the sugar cube in, and you time it. All right. So again, 4 different types of experiments. The first one is cold water, drop a sugar cube in, stirring, crushed, and then of course the hot water. The hot one you ask for me, and you record your times. What I want you to be thinking about, and the big question, and only one question I'm going to ask you, can you use the particle theory to explain why we have different rates of dissolving? I mean, hopefully at the end you'll see which rate is faster and which rate is slower. And it has to do, again, with the concept of the attractive forces between the particles, okay? And we're doing something to the sugar cube. We're manipulating the sugar cube, and we're adding a different energy force. So we have stirring, we have heat, and also we have the size of the particles that matter, okay? So really think about the attractive forces. We know that water molecules, right, their attractive forces are somewhat weak, which allows them to slide by each other. That's why this cup, or the water takes the shape of this cup, and I can pour water into different shapes, and I can split water, and I can shoot water. So I want you to be thinking about the particle theory, and if you can connect it to why the different rates of dissolving happen. All right, happy dissolving.